All right. Good morning, good afternoon, good evening, good night, whatever time it is. I hope you're having a good time right now. Hopefully, you guys had a good weekend. And if you have any questions or you just want to talk, don't forget I have a remind at Chun A or at Chun B. All right. So, what we're going to go over today, first of all, some announcements, I guess. If you guys still need laptops or if you guys are in need of any or you've been having problems with your laptops, the school is open at Thursdays, and I'll email you guys the link and the procedures on how to schedule an appointment to get that fixed. Some other things, obviously, yesterday was off due to inclement weather day. So that means we have a little bit shorter of a week. So we only have Tuesday, Wednesday, we'll have actual math material, and then Thursday, of course, is Riddle Thursday. So let's get straight into it. We are looking at quadratic functions today. Quadratic functions, and specifically, we're looking at vertex form. So that's what we'll be doing today. So, as you guys might remember, quadratic form or quadratic functions will have this kind of U or a boomerang looking shape, right? As opposed to linear functions, which have kind of a straight line, right? So, what we're looking at is how to write this as a function just by looking at the graph. And how do we do that? Well, I'm going to look for the vertex. And if you guys remember parts of a function last week, the vertex is always that bottommost point. In this case, it's the bottom. Or in this case, it'd be the topmost point. So it'd be right here. Or wherever that boomerang bends. So that's what we're looking at. So if we're looking at that, well, we know that this is right in the middle, smack dab at the origin at 0, 0. So this one is kind of the easy one, the one to always go back to. I always do f of x, and then I do x squared. So that is my quadratic function. Now, I can use a different letter for f. I can use g of x, I can use h of x, I can use y of x, right? It doesn't really matter because this is the name you're giving this function. So that's what it is. All right, so let's take a look at transformations as well, right? So we're looking at this one right here. And if you see this one compared to this one, you see that the vertex is still at 0, 0, which is good. That's awesome. But they look a little different here, right? This one looks, well, that one is facing up. This one is opening downwards. So, if anything, if you can see from here to here, I've flipped this one upside down, and then it looks like this one. So if I'm going to flip it upside down, I can use the same function. So f of x equals, I have the x squared still. But since I'm flipping it down, I'm going to put a negative right here. And that's all I need to do. That is my function for this graph. Not too bad, right? So, let's go back. I'm going to go back to this one because this is kind of always our base, right? That's f of x equals x squared, right? But how about we do a different one, slightly different. I'm going to do something like this. 1, 2, 3. So, now these two, I'm always comparing it to my base, right? So this is the original picture, f of x equals x squared. And then I'm going to compare it to this one right here. Now, for the most part, they're opening up the same way, and they look pretty similar. The difference, other than my drawing skills, is that my vertex is actually up here rather than at the very middle. So that's where it differs a little bit. So I'm going to find the coordinates of this vertex. Well, I start at the origin. I don't go left to right at all. So it's 0, comma, 1, 2, 3. So there's the coordinates of my vertex right here. So that's what I'm looking for. And that's essentially it, right? All I've done is move this entire thing. I moved this entire shape up 3. That's what this picture is doing. So, how do I write that? Well, I've got f of x. Now, I've got my x squared still. I still have my x squared. But when I move it up 3, all I have to do is add 3. So x squared plus 3. And that's my function. So whenever I'm moving up or down, all I have to do is at the very end add a plus 3 if it's up 3, or a minus 3 if it's down 3. And remember, I'm always looking at that vertex. Always look at the vertex. All right, so let's do something different. I'm going to erase the first 2, but I'll keep the last 2. Let's find my, there we go. I'm going to make a graph real quick. Now this one was moving up, right? So let's find one where it moves down. We got 1, 2, 3, 4, 5, 6. All right, so there is our function right here. And what we're looking for is that vertex. First step, look for that vertex, right? So I see it's right down here. That's my bottommost point. Awesome. Then I'm looking for the coordinates of that one. Start at the origin. I don't go left or right, so it's 0, comma, 1, 2, negative 3, negative 4, negative 5, negative 7, negative 6. I can count, right? So negative 6. And that's my vertex. Well, if that's my vertex, and I see that I haven't gone left or right at all, but the only thing I've done is go up and down. So I got f of x equals x squared. I haven't flipped it upside down, so it's still positive x squared. And then since this is a minus 6, I got a minus 6 right there. So that's how you would do vertical translations. And we'll go over more of translations, transformations tomorrow. But this is just finding the vertex form. All right, let's try another one. Let's see. Let's use red. And this one, I'm going to move it over here. 1, 2, 3, 4, 5. Okay. So, again, this is another same type of problem, except before I was moving up and down, I was flipping it over, right? But this time, I've moved it to the right. And if I move it to the right, I have to treat it a little bit differently, okay? So this is the one thing that you really do need to remember. It still looks like an x squared form, right? But I have to do something a little bit differently here, okay? It's not just x squared. right? But let's find the vertex first. So I start at the middle, I have to go to the right, 1, 2, 3, 4, 5. So the coordinates of my vertex are 5, 0. So it's not just x squared, okay? Before, you would just add the number at the end, right? But this time, because the 5 is in the x component, because we move to the right 5, you have to put this whole thing into a parentheses. So it's going to be x, and then I got the 5, close the parentheses, squared. Now I left a space in here on purpose. The reason why is because when you move to the left or when you move to the right, you have to use the opposite sign. Okay? So this is a positive 5, but when you're inside the parentheses, it's going to be the opposite of what you think it's actually going to be. So if it's a positive 5, it has to be a minus 5. So x minus 5 quantity squared. And that's it. That is my function. Okay, and we'll go over another one of those, just so you guys can have some practice on this one. All right, so let's do another one real quick. We got x, we got y. There we go. And let's move it to the left. And I'm going to move it to the left about here. And I'll make it 1, 2. So, since I moved this to the left 2, that means my vertex has to have the coordinates -2, 0. That's not bad. And we're just going to treat it the same way as we did here. All right, so I've got my f of x just like normal. Now, remembering that if I'm moving left or right, I have to be inside the parentheses. I have to flip the sign. So if I'm moving left, I'm in the parentheses. I have my x, and then I have -2 squared, but since it's in the parentheses, I have to flip the sign. So instead of a -2, it has to be a +2. And then that's it. I haven't moved anywhere else. I haven't moved up or down. And I haven't flipped it upside down. So that is my final function for this graph. Not too bad, right? All right, what we're going to do now is we're going to combine some of these. Before, we were just moving right, we were only moving left, we were only moving down. I'm going to combine some of them so we move left and up, right and down, upside down, right? So that's what we're looking for. All right, so we haven't worked with the upside down graph in a while, so I think we'll start with one of those. All right, so we'll do something like this one. If I can, there we go. 1, 2. Okay. So we've got this one. We see that it's been flipped over. Usually it looks like a U, but now it looks more like a really curvy N, right? So we know that it flipped upside down. Whoops, there needs to be 2 P's there. Flipped upside down, which is good. That's fine. And we also know that the vertex is 2 below, right? So I move 2 down. So that means our vertex has coordinates, what is that, 0, -2. Right, because I moved down 2, right? So those are my two things, and what that actually means is it moved down 2. So what we need to do is do the vertex first. So I've got my f of x equals, and since I'm moving up and down 2, I just have x squared. And then this down 2 means I just add it at the end. X squared minus 2. So we've checked off that vertex part. We're done with that one. Check it off. And then we have the flipped upside down. If you guys remember from a little bit earlier, flipping it upside down, all you have to do is put a negative at the front of the function. And that's it. That is your function. And we'll check this out as well. All right, let's do another one. This will be, I believe, my last one. So I've got a little coordinate plane going here. And let's move it around. I'm going to do something like this. 2, 3, 4. Okay. All right, so we're going to find out what they did to this graph, to the base graph to get here. So it's still shaped like a U, so it hasn't been flipped. That's fine. We see that it moves up 2. If we look at the vertex, right? If you find the coordinates of the vertex, it'll be to the right 4 and up 2. So vertex has the coordinates 4, 2. Not too bad. What that means is I moved to the right 4, but I also moved up 2, right? That's really what this vertex is saying. I moved the entire shape right 4 and up 2. So let's figure out how to write that. Now I've got my f of x, just as normal, equals, I've got my x, but since I'm moving left and right, because of that, I have to put this in a parentheses. Gotta put that one in a parentheses. I'm gonna leave a space here. I've got the 4, and the squared on top. Don't forget about this. Remember, this is what makes it a quadratic function. All right? And then I'm going to do the opposite. Remember, when you're in the parentheses, you do the opposite of what you think you're going to do. So it's not plus 4, it's actually minus 4. All right, so I've got the right 4 checked off. Don't forget about that up 2, right? Don't forget about this guy. But this one is fairly simple. Remember, all you have to do is add it to the end. So up 2 really means just plus 2 at the very end, outside the parentheses after the squared. And that is your function. So I've got the quantity of x minus 4 squared plus 2. And that checks off all of my steps. That concludes my lesson for today. If you guys have any questions, don't hesitate to ask, please. And some good tools for this assignment, if I can find, here we go. There's definitely Khan Academy. I can definitely link that for you guys once I post this one. And there's also a really good website. It's called Desmos. If you guys go to this is a graphing website. So I know a lot of you guys, actually most of all of you guys, don't have graphing calculators at home. So if you ever need to graph something, right, you need to graphing, then go to this website. Okay, all you have to do is really you type this in, you go to this website, click start graphing, and it'll pull up this huge coordinate plane, and then on the left side all you have to do is enter in your function. So say I had that one right there. So f of x equals x minus 4 quantity squared plus 2, right? You can type this entire thing into Desmos, the function, and it will give you the graph, right? It is a powerful tool. It is very useful. We might start using this a little bit more. But for now, just if you guys want to explore it, see the cool things that you can do on it, because there are some really cool things that you can do. Go ahead, check it out. Get used to the layout. There are some really cool activities on there that I think we're going to start using sometime soon this semester. But other than that, I hope you guys have an awesome day. Please stay safe. Please wash your hands. Eat some good food. Please tell me what good foods there are out there. But other than that, I'll see you guys later.